Alright, so Leetcode practice time. Today it is k closest points to a region problem in Leetcode. We are going to do two things. One is to find the solution for this specific question, and the other thing is to see how to solve this problem in the interview properly. So let's get started. So the question is, we have a list of the points on the plane, find the k closest points to the origin. And here the distance between 2 points on the plane is the Euclidean distance, and you may return the answer in any order, and the answer is guaranteed to be unique except for the order that it is in. Okay. So let's take a look at the first example. We have 2 points, 1, 3, minus 2, 2. And we are going to return 1 closest points to the origin. So pretty obvious, minus 2, 2 is the final answer because the distance is square root 4 times 4 plus 4. Okay, square root 8. Okay. Alright, so I think we know the problem, what it is asking us to do, but there is still some ambiguity we want to clarify. So for example, first thing is to clarify the ambiguities and think about the edge cases. So first thing I would ask is if there is any point that has the square root or the square root, how to say that, it is the square root square, I would say, if that could overflow the int 32. If it is going to overflow, then it can introduce some edge cases. But let's assume that it will not overflow during our computation for the distance to the origin. And the other thing I would like to ask is, what if there are fewer points than k? Let's say there are only 4 points and they ask us to return 6 closest points. Then the answer, so we are not going to get any points more than 4 because we only have 4 points. So let's assume that the interviewer gave us the answer that the number of the points in the input is always going to be larger than k. Then I think we should have all the conditions to be ready for us to do the job. Other than that, currently I think we should be pretty good. Okay, so maybe another thing is, okay, so, I was thinking whether k could be negative or equal to 0. If it is equal to 0, I think it's fine as well. If it's minus 1, because the length of the points is always going to be larger or equal to 0, so I think we don't need to worry about that. So I think we have clarified all the edge cases. Then let's get started. So the next step is to find the solution. So how to solve this problem? So in the general case, I would say for each point in the input, we just compute the distance to the origin and then do a sort after that. That's pretty obvious solution. For that one, suppose the number of the points in the input is n, then it is going to be n log n because of the sort. So let's think about if there can be some better solution. So suppose k is always, we have already asked the question at the very beginning. So k is always smaller or equal to the number of points in the given input. So why don't we just use a max keep to keep track of the k nearest points in the max heap. In this case, I would say to maintain the heap, every time we insert the point and delete and remove the k plus 1 closest point from the heap, it is going to be log n. So in total, it is going to give us a log k time complexity. So I think this would be currently the most optimal solution. So the time complexity of the solution is going to be O n log k. And space-wise, it is linear. Space-wise, it is linear. When I say linear, it is okay because we just need to store the k closest points. But if people argue that the return value can be counted into the space complexity, then of course it's gonna be linear to the number of the points. So I think we should be good about the solution. After we agree the solution with the interviewer, the next step is to do some coding to turn our ideas into real code. So in coding part, we care about your code correctness, of course, and the code readability, whether it is readable or not to people. So let's get started and do some coding work. So let's first define a class. Let's call it point. So the point will have two elements in it. So the first one, I would say it is distance. So we are going to use the integer to represent the distance. We don't need to use any long because we have confirmed with the interviewer at the very beginning no overflow for the distance. And the second one is the point itself. Then let's give it a let's define the how to do this. So it would be distance and int array point constructor. So this dot distance is equal to distance. This dot point is equal to point. Okay. So now we have the class defined. Let's define a max key here. So we are going to use a priority queue to define the max keep. Let's say priority queue. So it is going to be the point priority queue. Let's say its max keep is going to new priority queue. Say it's k. So let's make the k to be lowercase because it's not normal to have the argument to be capital letter. Let's say k and define the comparator. Let's say 0.1 and 0.2. So we are going to do 0.2 dot distance minus 0.1 dot distance because essentially we are dealing with a mask heap. So the next thing is to iterate through the points and compute the distance and put them into the priority queue. So let's say in we are going to do one pass through the input points array. So okay, so let's define another helper function. Let's say it is compute distance to origin. Input is the point. So let's just define the square of the square root. So we don't need to do any root operation for this. Let's just return this. So it is point 0 times point 0 plus point 1 times point 1. So this is how we compute the distance. So let's say max heap dot add new point. So it is compute distance to origin point, and the next one is a point itself. Okay, so we have already compute the distance and initialize another object called point, putting both the distance and the original point into the distance, into the instance. The next thing I would say is to maintain this max the max heap. So if the number of the elements in this max heap is larger than k, then that's the time we are going to pull the top element from this max heap. So if max heap dot size is larger than k, we are going to pull a thing from the max heap now. And after that, after we do a one pass, we are supposed to have the k closest points in the mask heap, and we just need to translate into the final output. So let's say k closest points is equal to, let's new this one to be k and 2, and we are going to iterate through it. So it is going to be point, and this is mask heap. So k closest, we will need to define a iterator. Let's say iter is initialized as 0. Iter plus plus is equal to point dot point. Alright, and finally we return the k closest point. So I think we are done with the code, pretty much code complete. Let's do some sanity check. So the final part is about testing. So let's use the first test case to check the correctness of the code. So k closest point, max heap. First of all, we define the max heap, and then for the first one, the distance is 10. So we put a point with 10 of the distance and 1/3 into the max heap. Not touching this if range anymore at all, because the size is 1, which is equal to k. And then for the next one, the distance is 8, so we put it into the max heap, and the size of the max heap is larger than 1. Now we just pull the top element from it, and now the max heap has only 1 point, which is -2 and 2, and then finally we turn it into a 2D array. Okay, so there is a typo here. Okay, closest point. Now close the point. So I think it looks pretty good. Let's give it a test. Okay, so compile arrow. Okay, so it's point. Another typo here. So compute distance to origin. Oh, okay. So we missed a return value type here. So then priority queue max heap y. So cannot find symbol. Is there any priority queue? Priority queue is here. Is okay. So a lot of typos here. Sorry about that. So now it's good. Let's give it a shot by submitting this piece of code. Let's be a bit quicker. Okay, so success. Now, so after we do sanity checking, it's better to think about some task cases by yourself manually instead of depending on this platform to do the checking for you. So for this one, how to increase the task coverage? So of course, some general task cases like this, like the first example or the second example. Other than that, I would say currently, based on our assumption, it is no, but if there is some other edge cases mentioned at the very beginning, so for example, if there are less points than k, what to do, we may do some check the conditions through some exception at the very beginning if the input is illegal, so something like that. But other than that, I think we should be pretty good with this piece of code. So and that's it for this coding question. I hope you enjoy and find it a little bit helpful during the time you prepare your technical interview. And if you like it, please please subscribe to this channel, and I'll see you in the next video. And thanks for watching.